Okay, I think we are now live. So, good morning, YouTube. Good morning, Peter. Uh, Thanks everyone who's come to join us today. Um, yeah, so we had a stream, Peter and I, about what was it? It was just over a month ago now, at the end of March, where we spoke a lot about the Python Unicode objects. And the intent for the stream today is to carry on with that uh, from the discussion we had there and try and prototype something that might be able to improve the flexibility of Unicode objects for the future, right? So that we can then go and have optimizations between, say, well, the primary motivator for me is Rust and Python, but we were talking a lot about UTF-8 formats, which is going to be broadly applicable for Python optimizations everywhere, right? Um, yeah, is that more or less what you're expecting for us to do today, Peter?
Yeah, one detail, could you share the URL of this YouTube stream? I don't see it on your channel.
Oh, interesting. It should be public. Yes, it's disappeared. Let me go find out what's happened.
Good, yeah.
Maybe we'll restart the intro again in a moment. I'm still not fantastic at navigating YouTube studios.
Yeah, the problem is they change it from time to time. So
I set it to public and then it didn't go public for some reason. So that probably means that nobody's been able to see the link. Okay, well, it's public now. Maybe I will I just go quickly do a post and say link is now public, just so that people might be able to discover it.
All right. We're live.
We're live, yep. And I'm just trying to repost it, because I guess if it was a private stream before by mistake, then nobody's been able to access the stream so far. Great. Okay. So let's get started again. Hold on. I need to make sure I've got my stream chat so I can see it if anything comes up. Okay. And we're good. So let's try that again. Good morning, Peter. How are you doing today?
Good morning.
Shall we? Yeah, so we're going to look at Python Unicode objects. Unfortunately, we wrote a good set of notes about what we were going to cover at the end of last stream. For reasons, you might remember I had some technical difficulties setting up last stream as well. Next time, perhaps, will be more flawless. I've lost those notes that we typed. We could go dig them out of the last stream, or we could kind of talk again from memory and explore towards where we're heading. I think you had some much more comprehensive information up on your end that we were talking about last time, which included the full matrix of features that we're kind of aiming for. So perhaps shall we start by just talking about that again and refreshing everyone's memory about what we're doing, and then we can begin prototyping?
All right. Once I find that.
That's totally okay.
Where is that?
In general, I think what we were heading towards, we're looking at in the stream right now, the Unicode object header file, which has got all the constructors and accessors for Unicode data. And I think we were talking about having maybe two new APIs, one for importing data to Unicode objects and one for exporting data from Unicode objects. And you've written about this publicly in the past and all the different options that we want to support. The problem with any new API is that even if something we have is well designed, we're going to be stuck, unable to fully switch over to it until existing APIs which can't support all that flexibility are deprecated. So we're going to have a long process here, but starting with a prototype of understanding how good, a new API with fancy new features could actually be will tell us whether it's worth going through all that deprecation migration. So I think that's where we got to. We wanted to explore whether it was even worth beginning this pathway. And hopefully the answer is yes. But we'll have to see.
Unfortunately, we won't see that until we make the prototype.
Yes. I'm hoping that that's going to be not too bad to get something at least workable, but we'll have to see.
So last time we talked about all the different shapes or memory layouts that Unicode objects can, or string objects can have in CPython. And basically, the ones that you create from the interpreter have this compact layout, which means the string data is right after the object header, and the object header can have different sizes. But there is also the non-compact mode, which some people still use, and it apparently is required for subclasses of Unicode.
Yeah.
So things like the Java bindings sticking a pointer to the original Java string somewhere in the structure will need the string data accessed through a pointer. So if we want to make any change, basically, if we want to, the important thing is for this use case, they need to use this structure directly. So if we want to change this structure, we need to make new API for their use case. Then we can deprecate the public structure for Unicode and wait a few years and then change it where we want.
Yeah. Okay. Okay, yeah, so that stops us doing anything with the actual Unicode itself. But we could, presumably, we could prototype what we want to do by making an internal subtype of string. I don't know how much that's going to create a mess. At least for performance and doing that kind of measurement, it should be fine, right? Maybe that's too complicated. Or we could just change the structure for now and see what it works like, and then go further.
Yeah, we can definitely do that.
Okay. So we should decide how we get going on this. I think we wanted to have a new constructor, right? So let's start by trying to work out what we wanted that to look like, and then perhaps implement it. We can have lots of not implemented parts.
New constructor could be.
Let's go to the bottom here. Okay, so this is where I'm used to typing so much Rust code that I'm gonna be slow typing the C code, but I'll do my best. Okay, so we're gonna create a new constructor.
We can use Unicode from string, which creates a Unicode object from my UTF encoded thing. So we can just reuse that. So
yeah,
let's decide on what the demo should be. So we're changing Python strings to be backed by UTF-8.
That was one of the possible things I think we talked about. I think we talked about what else was in there? There was the optionality of having a null terminator or not, for sure. There was the optionality of maybe having external allocation or like taking ownership of buffers or things like that, but we don't have to go down those roads yet. Those would be the sorts of things that we would need a new constructor for, right? But for just exploring whether we can store Unicode internally in Unicode objects, this would be good enough, right?
Right.
Okay. So we'll look at this one for now, and then we can start with that prototype. Okay, that makes things easier.
Yeah, the from string and size is probably the one to the more general one.
Yes, because from string we basically have to. Oh, I mean, it's the same.
Get the length.
Get the length and then do the same thing, and then you can guarantee it's not null term or it's not got internal nulls. But anyway, okay. So we need to support. Let's think about this. What we want to do is we want to. Is it fine for this constructor to assume that the Unicode is valid? The valid UTF-8?
No.
So
this one takes valid UTF-8. Well, does some
handling.
Does some validation then.
Mm-hmm. Yeah,
it probably doesn't match exactly what Rust's idea of valid UTF-8 is, but it can raise errors.
Yeah. Oh, I need to get better at navigating this. Here we are. This looks like it. Okay, so let's think about this. The first step is we need to, well, we store the UTF-8 buffer, right? When we do this. Do we? Actually, maybe we don't. Because we're decomposing
we'll store it.
Different.
So currently, strings are primarily backed by the array of the code points, and the widest type you need, and optionally, you have the UTF-8 representation.
And we
so
want to go the
think
other way
the
around.
state we want is where where you can have string that only has the UTF-8 representation. And if anybody asks for the array, you create that on demand.
Yes, that seems like the direction to go. Would we need to
currently the UTF-8 is always created on demand, and we want to basically make that one the primary thing.
Mm-hmm. And that means switching around where the buffers go, right? Because I think at the moment you were talking about that compact layout just now, and in the compact layout, it's that UTF-8 buffer is always external, and it's the code points that are in that compact inline.
Right, and I think we don't need to use the compact layout. For anything that's backed by UTF-8, we can use the non-compact layout, which has pointers to both.
Okay, that makes sense, and that's easier. So then the code pointer can be null for initially, and then we can fill it in on demand internally, I guess.
Yeah.
So that's the first step. Let's just write some notes for ourselves here. So create only UTF-8 array in the structure. Code point array till first. I guess it's char based API. Cool. So that's things like indexing, right?
We'll figure that out.
Yeah, I mean, some things might be easy, some things might be hard. at least this is the first way to do it, right? That we could just build the whole code point array as soon as we first need it. I think you've mentioned in the past that there might be more efficient ways to do that, but doing the whole array seems like a fairly safe thing to do. It's not going to create too much complexity. I guess we want to guarantee that the UTF-8 array is valid and has no internal nulls, probably. So we probably still need to do that validation as part of this construction.
That's a good point. Yeah, we probably want to add new API where you take a possibly invalid UTF-8 array and store that.
Well, hang on. We spoke about the surrogate pairs before, right? The code point based array is allowed to have invalid Unicode code points in it under the surrogate rules for CPython, but then your UTF-8 decoding fails. So the UTF-8 array couldn't represent that if it's guaranteed valid. So we could have
right. So yeah. So we probably need to repurpose the UTF-8 array into the possibly invalid UTF-8 array, and only expose it, like only use it for the original purpose after validation. So we need to have a flag saying UTF is valid, and not just use the pointer itself.
Yeah, flagging the structure to indicate whether the UTF is valid. It makes sense. So do we do... Okay, yeah. So then we could have an API to create directly, maybe with no validation, maybe with some validation. I guess we could start by thinking how much validation we want in. At the moment, PyUnicode from string and size will fully validate that it's proper UTF-8, right? Because it decodes the whole thing.
Right.
So it makes sense for this API to do full validation. And then if we wanted to have a new API which took a more expanded Unicode set, that could be a future constructor. And maybe does no validation, or maybe validates that it fits within CPython's rules. I don't know which way around to go there.
Right. Well, the surrogate pass encoding basically ensures that we've put in some bytes, and you can get those bytes directly out. And when those bytes are UTF-8, then that's fine. If they're not, then something happens to them.
Yeah.
So this is what we want in that pointer, like to be able to switch all of CPython's strings to this. Then we'll need to use that encoding internally.
Yeah. Yeah. Okay, so there's new constructors, I guess.
What I would probably do is change the PyUnicode from string and size to create a new string and just stick the bytes in it, and then call a validation function, which basically gives us the PyUnicode from surrogate pass and size constructor for free. Not for free. Need to write it.
Okay, so it will copy the UTF-8 or the passed buffer and validate it as surrogate pass.
Right.
And will we want to do that validation lazily?
We have lots of internal API that just takes an ASCII string without validation.
Yeah.
So we'll want that for performance.
I would personally love an API which is not just ASCII, but which is UTF-8, and the caller promises that it is valid UTF-8.
Yes.
Or potentially valid surrogate pass encoding, if that's a superset of UTF-8, right? So that could be...
No, valid surrogate pass encoding is arbitrary bytes, so that's easy.
Oh, okay. There is no need to do any validation here. No, is that true? I thought that the surrogate pass adds certain allowed Unicode code points, or does it actually extend to the full code point range by the time you consider everything?
That ensures that it means the string, like the Unicode string, isn't actually valid Unicode.
Yes, because it has.
But the bytes behind, but the bytes version of it can be arbitrary bytes.
Yes, but what am I trying to say? That the Unicode sequences don't map to valid characters.
Right.
But there is a controlled way, or there is an algorithm to interpret the ones which don't map to valid characters as arbitrary bytes, right? This is the surrogate pass stuff. But
right, yes.
Is it the case that every possible byte sequence?
Yes, that's the whole point. Yeah, every possible byte sequence can be converted to some string, which can be then converted back losslessly.
Right, but when you do the string conversion, do the strings that you produce cover all possible byte sequences or not? Byte sequences is going to get confusing. Like can you get to every possible Unicode sequence from that conversion of arbitrary bytes to, because I might be wrong here, but I thought that when you encode the arbitrary bytes, you only need to encode I can't remember whether it was single bytes or something. So there's only a few Unicode sequences that you need to introduce which are not proper characters into the superset, right? You don't need every possible Unicode sequence, of which a lot are still invalid, even in the surrogate pass encoding, or am I wrong?
Okay, now I've lost you. Sorry.
Okay, maybe I should try and how can we try and write this down? So we have the surrogate pass encoding. Yeah, so I mean, GitHub Copilot has filled this in, right? So we have bytes in this range, which get moved as Unicode code points into this range, which aren't code points that have anything meaningful, right? So then we can.
So what are those? So with surrogates, you always need a surrogate pair, right?
Yeah. And these are the surrogates, I think.
And those are, so you always need a high surrogate and a low surrogate, or leading and trailing, right? So these are the trailing surrogates, which are not valid in Unicode.
In UTF-8.
Like these cannot start the surrogate sequence.
Yeah. And so in CPython's encoding, these exist on their own, right? Unpaired. Because the arbitrary bytes that came in will be sent as these unpaired surrogates. So that's not a proper Unicode sequence, right?
Right.
But we're not still. What am I trying to say? But for example, this encoding sequence doesn't still populate, or it doesn't leave unpaired high surrogates, right? If these are low surrogates.
Well, you're not really supposed to use surrogates in UTF-8 anyway.
Okay.
surrogates are for UTF-16.
Okay. This is where my technical knowledge on this gets a bit hazy. But still, there's what am I trying to say? That there are raw byte sequences. If we just pass a char pointer array, which isn't valid even in the surrogate pass encoding, I think is what I'm trying to say.
No, this will decode arbitrary bytes to a Python string in a way that you can get those arbitrary bytes back. That's the whole point of surrogate pass encoding.
Yes, that's
if those bytes are valid UTF-8, then you get the UTF decoded string. If they're not valid UTF-8, you get something weird.
Right. And are you suggesting then that if we pass the arbitrary bytes into the constructor, that the constructor then does the encoding?
It might.
Because I think
I'm suggesting the internal constructor just stores those bytes as they are, and when somebody asks for the UTF-8 representation, that's when we can do the check and tell them, no, sorry, this doesn't have a UTF-8 representation.
Yeah. Okay.
Because the UTF-8, getting the UTF-8 representation is already fallible in CPython, right?
Yes.
There are some Python strings which you cannot encode to UTF-8.
Yeah. Okay. Maybe we should just go and implement it, and then the full problem space will be clearer to me on this particular one. We've got one message from Vishwa. It says, "Hey David, how are you? I'm all right, thanks. I'm looking forward to figuring this out. We're exploring the UTF-8 space at the moment. So let's just do this, and then maybe the problem will become clearer as we
let's put those notes to a different file, because I don't think we'll be touching this one that much.
Okay. Where do you think we need to go? Surely we need to touch Unicode from string and size.
Maybe let's put it in the header.
Sure.
So what I like to do when I'm changing the internal representation of stuff is rename all the fields of the struct that will change meaning, and then the compilers will tell you what needs to change.
Okay.
Flags are probably all right.
Well, so what's going to change meaning? We need to change
UTF-8.
We need to change Unicode object. The data has a void pointer any already.
Yeah, so this will now possibly be null.
Yes, because that's the code pointer. So this could be null. So we probably want to
change all of those names, all of those 4 names. Just add a maybe null. No, the data's fine, but all the 4 pointers themselves.
Like this.
Maybe null, yeah.
Oh, let's just go for lazy any for now or something. Okay. And then should we run?
That's the backwards compatible change.
We'll need that. We can explore that further in a moment. I guess we can run a compile and start. So I haven't actually started a compilation at all in this directory yet. So what's it? It's make. We need to do configure, right?
Yep.
Any preferred flags you recommend?
-- with PyDebug and -C.
Capital C
being cache. So when you do that next time, it'll be faster.
When I run configure, you mean particularly?
Yeah.
Oh, okay, cool. All right.
So this takes a while.
Yeah. Okay. Yeah, I was hoping to have the IDE configured for C development so that I'd get more sensible errors in line, but I didn't get around to achieving that. Maybe that can be one of the improvements as we slowly cut down on the technical issues month by month.
Oh, I think we're fine.
Yeah, I'm very used to working in Rust and Rust Analyzer, where the IDE is pretty good at giving a comprehensive inline completion and type analysis and things like that.
Yeah, get that.
Okay,
Okay,
so
let's run make just make without the dot slash.
Oh yeah, sorry, of course.
J and however many processors you want to give this.
I'll do 8. Oh, okay.
And that, of course, failed very, very fast.
Course, yeah, we're expecting it to fail. Because let's see, we've got all of these errors all over the place. So let's have a think about what we're going to have to do with these constructors, all these accessors. PyUnicode non-compact data could.
Yeah, so this needs to call some function to populate this. So let's just make it a no-op right now. The important thing here is to figure out how to handle error handling. But we don't have any way to raise errors in the current API, so the only thing we can do is make any allocation here fatal.
Yes, and then we just have to abort. I think we spoke about this at least initially, but yes. This is a private
server. At least for the demo, we need to do that.
Okay, fine. So
we call some new function we're adding. So let's call it PyUnicode fill data or something, and
yes, do we want it to be a PyAPI func still?
Yes.
And let's think, is the return type maybe just int?
Well, this...
We can think about that in a moment, perhaps.
Just make it void, because it can't fail.
Can't it? Isn't it if the decoding fails that it will fail?
Well, it'll only be called in contexts where we can't bubble the error up, so it'll need to call the it'll need to.
Let's make it really obviously bad then.
Yeah. Right, and yeah, it just takes the Py object.
Yes, and you don't actually need to name the arguments in the header, do you? Which I find
you can, but I think people always complain of when you do that, so just make it as a string or something.
I complain. I think it's helpful.
Yes. Oh, well, yeah. Yeah. This name doesn't do anything, so we used to just put it in the documentation.
So you prefer not to have a name?
No. I prefer having names.
You prefer having a name too? Yeah.
Like for C, it doesn't matter at all.
Is Unicode what you might call it, or?
And it's internal API as well, so just wrap it inside YouTube.
Let's go with op, just because that seems to be what's been used elsewhere. Yes, of course we won't expose this. Okay.
All right. Now you just call that, and that gives you the permission to use lazy any instead of any.
Yes. So is that going to be the case that we should put this all over in every call site for now?
Yes.
Okay. this is where I might suggest, if you're game for it, this is the kind of thing where I find LLMs can be quite handy, because we've now
There'll
got
be
a
like
really...
5 sites, hopefully.
You think it's only 5? All right. Well, I guess we can check that.
This should be abstracted already. Like this Python
yeah.
code not constant data, that's the thing that everything else should call.
You're right. There's only about 1, 2.
Well, this is not all the errors you'll get.
Okay, it stopped early. Fine.
But I don't think we need
okay.
any help here yet.
If you think it's not so code fill. No, I've got a mistake, haven't I? Because I haven't forward declared that function. I put it at the end. That's not valid in C, right?
Right.
So let me go get that and put it near the top. Is that how you would do it? Or would you put it in the...
Put it after the struct, but it doesn't really matter.
Okay, yeah. So here. Or why not put it just before our first need for it, which will be probably here.
Yeah.
Applying Unicode data as a symbol, but otherwise... Oh, hang on. This is reinterpreting... Oh, because this is compact. We're not doing compact, we're doing non-compact. So this should always be okay. Oh, right. Yeah, okay, fine. And then...
Well, you can use the new thing.
So that's probably going to fix the header, but we might have some changes in the C file, I guess. Yeah, okay.
Yeah. Oh, now we have... Yeah, but they're all from macros. By Unicode data any. So... that's here. Line 165 in the C file. Yeah.
Yeah, we've got to it. So now we're going to have to... this is no longer a single expression, right? So do we change it to a static inline function?
Yeah.
So we go static inline void here.
Wow, but this is used as an L value sometimes, I guess.
Let's go look for
which means
yes, it is.
You need to make 2 functions. You need to make keep this and add a PyUnicode data set, PyUnicode set data only.
Yeah.
And make them both static inline functions.
So PyUnicode data any. That's the set actually that it's tried to produce for us. So now, of course, this is not helpful. Well, hang on.
Yeah, that's exactly it.
That's the right shape for you? Yeah, you're happy with the cast happening inside of the inline void. You don't want... Because I've seen the pattern as well, right? Where sometimes we'll then redefine the symbol to cast it outside. But I guess it's functionally equivalent, right?
Yeah, that's used in public headers.
Whereas this is fine here.
Here, so if you have the underscore, it's usually skipping the error handling and type checking.
Yeah, so we can just do the cast internally.
And I think the cast will do an assert that it's actually a string.
On debug, you mean?
Oh, yeah.
Yep, you're right.
Yeah. Okay, data NA, you need to have that. You need to type it as a string instead of void, and that's it. Oh no, void star. Yeah. And that returns a pointer, right? You need to return there.
On this one, yeah. Like this.
Yep.
And
Now
this
remove the
one,
define.
hang on, does this one need to fill or abort? Possibly not.
Yes, that needs to fill.
Well, what's the downside of putting the fill here is that then we're introducing branching on every axis, which we probably need because
So we can do two things here. We can either we need to put the fill here. The other thing we could do is rename this function and add the fill in all the call sites.
Yes.
But for the demo, we want to do the fill here, and we'll optimize later.
Well, hang on, but
like if we're defining this function with the semantics that it had, which means under this name, then we need the fill here.
Is it possible though that if we're moving towards the UTF-8 well, hang on. Are there operations which would currently go through this buffer which might want to prefer to go through the UTF-8 buffer?
Yes. So, yes, they are. But let's do that later.
Okay, so we'll start by just having this easy thing.
Yes.
Okay.
And remove the define and try again.
Yep. And we're going to soon get to a point where we have the symbol define not implemented. Oh yeah, we need to change the call sites now.
You need to put a semicolon at the end. You're not in Rust.
Sorry?
You're not in Rust. You need a semicolon at the end.
Oh. Well, this is a Frankenstein because in Rust I wouldn't have return either.
Yes.
trailing expression. Okay, but we've also misused the call sites. We need to change these ones.
Yeah, just put in set.
Oh, well, hang on. Yeah, there's only a couple. So let's see, which ones do we want to change? We need to change this one. Ooh. That one's interesting. Why is it setting it to null?
It's probably a constructor thing.
Unicode subtype new. Okay. Okay, fine. So then it's going to allow some allocation and things. Okay, fine. It's just initializing it to null while constructing. Okay. Right, let's see how we do now.
But it's good that you spotted it, and that's why you don't use LLMs. To see all the call sites you're changing.
Yeah. Well, you can inspect what the LLM did after.
Yep. So
once you realize your program seg faults.
I'll see lots of that.
Here we are.
Yeah,
so there's direct access here. This is in Unicode check consistency.
Yeah, just fill it in and use lazy.
Are you sure? Where does this check consistency get called? It's
all the time.
But isn't that going to have the impact that basically our whole laziness thing falls away if check consistency is filling it in?
Yes. But let's do this for now and revisit it later.
Okay. All right. Sure.
We'll want to revisit all of these.
I suppose it would have been nice to see the any possible performance win come sooner, but there we go.
Or we can just skip the check, I guess.
Oh, we have op. That's what we want. We do want that. Yes, I mean, maybe that's what we got. Because I guess we don't check the... What do we check? We check the data.
Yeah, that's a good idea. So let's skip the check if null. But if null, we want to check that the UTF-8 buffer is
separate.
Is set properly.
Let me think about this. Because...
Well, we either need the UTF-8 buffer or the lazy data.
Oh, there's also the ASCII case where the UTF-8 buffer goes. Is the same.
Well, that's where you knew in advance it was ASCII, so we don't really need any of this for that case.
Okay. Yeah, because that case is already covered anyway. That already works fine. Right. Hang on. In this case...
Instead of fill...
Yeah, when this branch happens, if it's non-ASCII, is the UTF-8 representation guaranteed filled already when Unicode check consistency is called? Or is it... Because this is interesting to me.
So that's the underscore, so that might give you nulls.
It looks like it will. So it looks like this check might load a null pointer and just compare that the null pointer is not the same as the data pointer.
Yes.
Which is totally valid. But they might both be null if we are...
No, they cannot both.
Hang on.
That's what you want to do. So yes, instead of the fill data or do an if we have the lazy any, then do this check. Otherwise, we need to check that Unicode UTF-8 is not null.
So yeah, else if...
No. Like in line 634, instead of filling, you want an if.
Yeah.
Or maybe the line after you already have it a local variable.
So if it's non-null,
then do the previous check, all of it. No, just all of this.
Does the kind...
So if we don't have data, the kind should be set to 0 probably.
Yeah,
you don't know.
Should we check that for now? Hang on.
Just do all of the current check in there. Oh, okay, we can do that.
Yeah.
But we need to check that UTF-8 is set. By Unicode UTF-8, yeah.
Isn't that actually still good enough? Because we know that this is null. I mean, it's more explicit to write it like this, I guess.
Explicit. And you also want to check the UTF-8 length.
Oh, yes, you do definitely want to check. Well, hang on. What happens if you got past a null UTF-8 buffer? Then it... oh, an empty one, sorry. Then is there a fast path that would...
Oh, I probably want 0 or -1 there. Well, I don't know what the length is set to if the buffer isn't filled yet, but there should be a single value there. So either 0 or -1. Just check 0 and we'll find out soon enough.
Hold on, you mean check?
Oh, it's in compact as well.
No, hang on. No, that's for ASCII objects. So we're not an ASCII object.
Ah, right. Okay, so don't check this. It's fine.
But the hold on. But there must be a length somewhere. But
Yeah, the length of the UTF-8 is somewhere, yes.
Let's go back and look at the structure. The UTF-8
length and compact.
Oh yeah, okay, fine. So that was correct. Sorry, because compact, where we were just editing, is the compact Unicode object. So that is the UTF-8 length. Oh, hang on.
Yep.
No, but
No, we need to use PyUnicode object for this. So
yes, it's a PyUnicode object which contains a PyContact Unicode object as a base because it's got the additional data pointer. So the UTF-8 representation is still not compact, despite the name being a bit confusing. So we are okay. UTF-8 length we do want. I guess we want greater than 0, probably.
Oh no! Well, the empty string is a bit.
I would
okay.
like
The empty string is
to always
ASCII,
be an ASCII one, right? So
yeah.
So I think,
yeah, we probably want to check in whatever constructor we have.
yeah, because we can fast path it, right? Isn't?
Yes, and that should probably be somewhere else.
What do you mean somewhere else?
Maybe look up. Do we have a check? Like scroll just up. We have something about 0 size. No, at the beginning of this function.
Don't think so. What about PyUnicode from string size? PyUnicode get empty, right, is already passed from. Oh, interestingly, if PyUnicode from string gets just a null terminator, that doesn't go through that pathway.
Or
maybe it will inside.
It does.
Maybe inside PyUnicode.
Check size. No. It checks the size. Okay, you're scrolling much too fast now.
Sorry,
so PyUnicode decode PyUnicode from string and size.
This one's okay.
Oh, so that one's okay. Yeah.
If this is get size greater than 0, it goes for PyUnicode get empty. This one doesn't have that. It's got an overflow, but so unless decode UTF-8 stateful does it.
It probably does.
Let's have a check. Hopefully it does. It seems like an obvious place for it to be done. So this one just goes to Unicode decode UTF-8, which I think just goes to the implementation, hopefully.
Yeah. It was.
It checks if size is 0, returns empty. So okay, it's fine. It's there straight away. And then the impl is presumably not checking the size because that's already checked in the other one. Okay, sorry, I'm jumping around a little bit while I read. So Unicode decode UTF-8 is doing the size check. So I think.
Well, so the important thing here is any string object that doesn't have the character data filled will be created by our new constructor, which can check this size. So greater than 2 is correct.
For check consistency.
Yeah, for the one you're changing right now.
Yeah, where did we go?
So what I do is press Control-Z, which will teleport the.
That's a bad idea.
We do.
This file's very long. Okay, here we are. So you're right.
And everything after that else you want to put in the
Empty string should never reach this pathway will be the empty string singleton.
Yep.
Yep. Okay, great. So
I guess you can also check that the string length itself is greater than 0. Oh no, you can't do that. Sorry, never mind.
Because that's the data, right?
Yeah.
Okay.
Yeah. So all that's left is put that.
That goes up. And does any of this make sense? That one we don't need to check anymore because that's right there. Kind should be set. Compact should be 0 because compact is here. Can we just delete this? It's sort of a redundant there. Oh no, not necessarily, because you could have other values.
Oh, we're in the wrong branch here, aren't we?
Sorry.
Oh no, we're in the
right. This is the compact branch. This is the non-compact branch.
Yeah, good. Okay.
Does it make sense for compact to be anything other than 0 or 1? Does this check even make? Is it even needed?
Yeah, that's a bit.
Because it's only a single bit, right? And we know that. So that isn't that statically guaranteed that this will either be 1 or 0. Like the compiler will never load it to anything else. So we can delete this line. A little bit cheeky, but we can, right?
Sure.
We don't need to.
It's a debug check, so just leave it in.
Oh right, okay. So it would be it's optimized out.
Yes.
Okay. So okay, fine. It makes sense to have it then. Sure. Okay. Well, in which case we might as well have as many checks as we want. That looks fine. Those were all the existing ones. So we got this new branch. Cool. All right. Let's see what we get. Now we've just got the oh no, and we've got one more usage site.
I probably misspelled the name.
Unicode dump.
That's the Y in the pi should be lowercase.
Sorry. Oh, here. Yeah. Oh, I see. Yes, that wasn't unimplemented function yet. That was to invalid symbol or invalid name. This one, where were we looking?
Sorry, line here. 1278. Yeah.
This one will need.
You need the fill, yes.
I think so. Should we just change this one to use the macro?
No.
Or the new function Unicode data any. Like this.
What is this doing?
It's some kind of debug symbol to the data. Where's data used? It's printing out the data pointer. Is that this format?
Yeah, this is not important. Just fill it for now. We'll revisit later.
Yeah, we can do it like this though, right?
Yeah, sure.
Seems more correct than having the separate fill call. Or maybe it's fine if it is null. I don't know. We'll leave it for now.
I mean, I think this is supposed to dump the internal representation. So.
So then anything, it's probably better for it to be null.
Yeah.
It helps us debug without.
Yeah. Just.
Yeah. Okay.
Right. Next one. Traceback.c. Oh, dump ASCII.
Why does it use data? It doesn't
just fill.
use.
It's lazy.
Hang on, but I think it only uses the data if it's an ASCII string. Oh wait, hang on. No, it does. It uses data here.
Yeah, just fill it.
Yeah, we'll need to because this is using the old show points path for now. We might want to change it later.
Yeah, we might change it later if it becomes a bottleneck, but
and this is going to have to use the. No. This is use. Could this can use the header symbol? So
yeah.
it's Unicode data.
Oh yeah, yeah, I can use that.
Is that right? Like this.
I think that's public even. Is it not?
I'm sure that was in the CPython. Isn't that what we?
Yeah, that's public. That's without the other.
Data. What do you prefer to use, the public or the private symbol here?
And here the public one.
So we should be doing this.
Yes.
Okay. And really, we could benefit from having a UTF-8 specialized branch here, but that's for future.
Oh, definitely. We can benefit from a lot of those.
Okay.
Unicode. Oh, good. We got to a linker
there.
error. Nice.
We're there. So now we can do this. Where do you want it? Right at the bottom of the file?
I think now we should look at the constructor, like Unicode from UTF-8 and size.
You don't want to implement the symbol yet. I guess it doesn't do much, does it? Hang on.
Oh, look at what it does now. From strings and size.
But what do I mean? We don't want to implement the missing symbol yet. You want to go look at the constructor to work out what we're doing.
Yes.
So we have both of these, which go to Unicode decode UTF-8 stateful. So this is the symbol or the function we actually want to change, I think.
Yeah. Yes. Let's go there.
Hold on. But this is doing validation, and we spoke about this. We said we want to not validate. So maybe we should implement a new function which we can just change this constructor for now.
Yes, let's change this constructor for now and make it call the new thing.
Okay, so we can have a new
UTF from string and size.
Unicode from. Do we need this to be static or anything to not expose it? No, symbol visibility is hidden, so I don't need to do anything, right?
Right.
From what do we call this? UTF-8 unchecked. Or we do? I don't think we were doing validation at this point, were we?
Maybe name it from surrogate path.
Is there a good name for the UTF-8 with surrogates?
There's a bunch of names for similar concepts.
What does the PEP call it? Or ancient PEP that talks about surrogate paths?
Oh, I have no idea.
I think it's PEP 383.
Yeah.
does it give it a name? Based on an idea called UTF-8 8B. That's the idea though, that's not the actual name. It doesn't really. Okay.
Surrogate escape, yeah, that's the name. That's the correct name.
Like this, or just surrogate escape?
Yeah, from surrogate escape is probably best, yeah.
Yeah. Okay.
So this one needs to fill in the structure and then.
Yeah. So we have to allocate and all of this. This is where I'm going to be.
Yeah.
Does Unicode new with a zip? No, that's not going to do it. Have you got an idea of a function we can look at to start from?
Yeah, that's a good point.
Because Unicode new won't do what we want, I don't think.
Nope.
Because, yeah, size is 0, just immediately skips it. We want... I guess we could just create one, couldn't we?
Probably need, yeah, we just go PyObject malloc.
What? Is there a malloc call in here? Oh, yeah, here.
Yep.
Yep, okay, so we can do that. Then we can cast it as a Unicode object and we can fill in the fields we need, which will be something like this. Okay, I might just copy this block for now and then we can do this. Oh, we might be able to use PyObject new, possibly.
Yeah, we might.
Okay.
Yeah, let's do that.
So we can do
but that might, call the constructor, which we really don't want.
I
All
guess
these are really confusingly named. Allocates a new C object. Avoid calling this directly.
Here we are. It does call PyObject in it. Yeah, so we just want to do PyObject malloc. Fine.
And yeah, we also want PyObject in it, which doesn't call Python under init. It fills in the type.
Okay.
Yeah, so do PyObject new here. Yeah,
we do want that. Okay.
And you need to.
So yeah.
Oh, that reads the size.
That's so. Oh, is that?
Yeah, who knows what the official size here is? Yeah, just do PyObject malloc and PyObject in it.
Yeah, because the problem is that we
sizes are different. Yeah,
we could go look, right.
Yeah.
What's the symbol? The type object called? Unicode type. Here we are. TP basic size is size of PyUnicode object, which is what we want, right?
Yeah.
So it should be okay.
So
let's use PyObject.
PyObject new. Yeah.
It's cleaner.
It'll be fine.
And it takes PyUnicode type.
It takes PyUnicode object and PyUnicode type. Like it's a macro. It takes the structure. That's the one with the underscore.
Oh, we should use the public symbol.
Yeah.
What's the difference? The PyObject symbol takes.
Well, the private symbol is somehow special, and nobody bothers to document how it's special. So it's always better to use public API, unless you have some reason not to.
It says avoid calling this directly to allocate memory for an object called TP-alloc, because this allocates by calling PyObject malloc and then initializing it. Fine. Okay, but fine. We're not just allocating memory. We are actually beginning to populate. So I think that seems right. Okay, fine. And you say it takes the type, which is the
PyUnicode object, the C type. Right.
Which just does the cast.
Yep.
Is the only thing that's different with the underscored one. Fine. So then we need here like this.
Yep. And name it Unicode. Be consistent.
Yeah. And we just need to do the error handling, I guess, like that. We don't need to do the cast. We don't need to check. Well, hang on, let's just decide. These are the fields that we're getting filled. We also need to have the UTF-8 stuff filled. So Unicode UTF-8 length. Oh no, we need to cast it backwards to achieve that, right?
So what do we need to fill? So PyObject new will not zero fill the memory, so we need to make sure we fill everything here.
Yeah, okay. We're going to go look at the structures. Should move that onto the right, then we can have it easier. So we've got the state to fill. So the head is filled. The length is going to be what? 0 for now? -1?
Yeah, that's a good point. Yeah, that needs to be -1, and we also need to rename it because it changes semantics.
We'll worry about that in a moment, I guess. Okay.
And so you need a PyUnicode set length macro here.
What? Because length will lazily fill the data as before.
Yes.
Okay, so we'll deal with that in a bit. The hash is at -1, fine. Now we need to look at the compact or the state, which has interned is
interned is 0, kind
is
that needs to be lazy
0.
kind.
Oh yeah, we need to do that.
Kind.
We're gonna have quite a few problems with that. Okay. Compact is
0.
ASCII
is ASCII is 0.
Well.
This flag determines the underlying structure. It's not using
and compact is set.
It's not using the PyASCII object structure itself. It's using Unicode object.
I think it's worse than that because I'm reasonably confident that this has a Python level observable behavior in that if you have the isAscII function, it just checks the flag. Yeah. So
That
if we pass an ASCII only buffer here, you get
sucks.
you get the wrong behavior. Let's for the moment.
Oh, if ASCII is set and compact is set,
then it's a structure.
So since we have this compact 0, this okay, so this needs to be lazy ASCII. Because we don't know yet.
Yes, because presumably the decoding is going to be already working out whether it's ASCII or not and filling it correctly for these constructors.
Yes.
Yeah, fine. It feels like it might be nice to have constructors like Unicode from ASCII, or presumably there is one, is there?
There's an internal one.
There's an internal one. But, you know, you could in principle have...
we're not touching that one.
Yeah, we could but for Unicode strings which you know are ASCII, that could be an optimization for later, right?
Well, for Unicode strings which you know are ASCII,
well,
I've
stated that point.
You don't make them lazy.
Yes, but no, because if the caller knows, then you can set the data pointer and the buffer point, the UTF-8 point is the same, right? We're looking at in check consistency, so there becomes an optimization.
We already do that. We already do that in CPython.
Yes, exactly. Oh, but you're saying you want to do that lazily. We could do that in our implementation of fill.
No, we don't. We cannot do that lazily. Like if you know at the start the string is ASCII,
yep,
then you use the PyASCII object structure, which only has one pointer. Well, it doesn't even have a pointer, which only has one buffer.
It's got the compact one, right? That's if compact is set.
Yes.
But you could have a non-compact ASCII layout here.
Yes.
Anyway, okay, we can come back to that. Okay, and then statically allocated is 0. Yep. While we're talking about this, we had the possibility we spoke about. We spoke about a flag for invalid UTF-8, right?
Let's not do that now.
You don't want to add that flag?
Not yet.
Shall we add a fix me?
Just rename lazy ASCII.
Invalid UTF-8.
No, I don't think we need that note even.
Okay, if you're sure.
Just rename the field to lazy ASCII.
Yeah. Okay. And so that's this state filled in.
Then we have UTF-8 length,
which is
finally something we know.
and
that's PyCompact object, so you need to cast.
Is there so we need to just cast it, right? We just go PyCompact Unicode object compact equals. Is there a macro for casting here, or?
Well, maybe.
Yeah. Looks like if we've got one.
Right. Then UTF-8 length and
it has an assertion in it. Fine, that seems okay. Compact UTF-8 length is the size, which is nice, and the pointer
Yeah, Pyman malloc.
Oh, we need to copy it, of course. Yeah.
Yes, we do.
Uh,
Yeah,
do we
Pyman
want to
malloc.
change this to be change the field now that we're allowing this to have invalid UTF-8 in it?
Yeah. Yeah, we do.
And that's probably better than having a separate structure, right? Like we could have a PySurrogate escape object and a flag, but that just adds complexity, right?
No, you cannot do that because the object we have here is by Unicode object.
Fine, sorry, yes. Then it doesn't make sense. So we might as well just change this field.
Yes, and we need to add a new flag for isValid UTF-8.
Yeah, which is what I was suggesting previously. Should we do that now?
Sorry for that. Yeah.
And then we have to make this 23.
Yeah.
So this is the surrogate escape pointer is known to contain only UTF-8.
Yes. All right.
Buffer, is that a better name than pointer? Probably. Okay, so we're going to have a lot of pain. All right, so now we need to use Pyman malloc.
And the line below, I just said it.
Why is wrong? That's not right, is it? So Pyman malloc. Oh, I see. We could do it right here, like this, and it's the what's the API for Pyman malloc? Just the size. Okay. So yes, that is right because it's the byte size here.
Yep.
And then we want what, memcopy?
If that turns out to be null, then you decref the Unicode and return.
Yeah. Uppercase decref like that?
Yeah, and return null. And you need parentheses around the condition and C.
Yep. Okay, and then memcopy is also. I forget the order.
I do too, so I just did memcopy and it's destination source and size.
Destination source, that way around. Feels really intuitive. Okay,
yep.
So we want to put. Though maybe it makes sense if you think about it. Destination and then the 2 data points for what you're getting from. So we want from, you, and size.
Yeah. And now rename all the UTF-8 to the surrogate panel.
Yes, here.
All right. What's the next one?
Yeah, and it definitely makes sense to do it this way, doesn't it? Rather than guaranteeing that there's a UTF-8 valid buffer, because otherwise we can't have just a single buffer to describe the surrogate escapes. We'd go back to where we were before. Yeah. Okay.
Do we want to rename the UTF-8 length field as well? We probably want that, right? Well, maybe we don't need to.
One thought, just while we're talking about this surrogate escape stuff, I think if you ask for the UTF-8 representation at the moment, you will get a decode error telling you what failed to decode.
Yes.
Whereas if we're going for this surrogate escape and flag approach, then, I mean, you could still send that decode error, but you'd have to do a re-decoding. You can't just check the flag. You'd have to check the flag, see it's not valid, and then re-attempt decoding to get to the error.
Oh, so you get the correct error.
Or we could change the error to just be like not valid UTF-8, but it's not very helpful.
I don't think it's worth optimizing that case, so we can just redecode.
Redecode, find a useful error, and then
I'll
go with that.
So we're doing a demo, so we're doing the easiest thing that works anyway.
Yeah,
then we'll see where the bottleneck is.
Yeah, I guess I was just thinking that if we know that if we think, I mean, that error shouldn't be hit a lot, I guess. So,
definitely.
Okay. Okay, so just for time sense, I think I've got about half an hour remaining for today. So we'll see how far we can get with this in the remaining half hour. Hopefully something that compiles. Okay, so we've got...
Oh, there's 3 names. Probably not.
And we need to set data to...
Okay, then we have the data, which lazy. Yeah, we need to set lazy a to null. And I just return that and see what happens.
Yep. And now we're ready to do this, right?
You need to cast it to PyObject.
Is there a PyObject cast macro?
Maybe, but...
You think just doing the cast is...
I mean...
It's probably shorter, to be honest, isn't it?
The cast macros do an assert.
And debug. Okay, yeah.
If you're casting to PyObject, there's nothing to assert, really.
Would you do spacing like that?
Yep.
Okay.
Hey, that'll give us a bunch of new compilers.
Okay, Peter's microphone is
happened?
Too loud. Let me...
What happened right now?
Oh, no. What's gone wrong?
So YouTube is still live, but I lost your stream on Google Meet.
Oh, okay. I think I will try and bring that back for you. You are too loud, is someone reporting. Let's fix that.
All right, so let me continue where I left off. The new PEPs are PEP 8108.
How's that for everybody?
PEP 661, PEP 799, PEP 799 again, PEP 831. Is it good now? 798, PEP 686.
I'll try and set myself a bit louder as well.
I think you can see the volume levels in OBS, and that should give you an idea of.
So I've given myself some gain and put you a bit quieter. Hopefully that will be a better level for everybody. The IDE is Z for Ubi, who's just asked. Right. Please give me a moment while I give Peter a screen share back. There you go. You should have it.
Yep.
Great.
Confirmed.
Okay.
Right. Let's try to compile this.
Okay. We're going to have hundreds of compiler errors now because we've changed almost everything. So that's fine. We'll just work our way through it.
All of these should have accessors in most cases.
Yes.
But we'll definitely need to change the accessors everywhere.
Oh, missing that to start with. Okay. Yeah, so this will need to do Unicode fill data. or abort. UV, I sometimes
lazy ASCII.
Yeah. I've just been asked if I use AI tooling. I can do. For open source contributions, I prefer not to for various reasons, but it depends a bit on the project and what's going on. Here we're not using any, well, I've got GitHub Copilot running, but we're otherwise crafting this ourselves and thinking carefully about what we're doing rather than just throwing this over the fence to the machine to churn. We might use an LLM later if it makes sense, but only if it's relevant rather than just blindly trusting it. Okay, so this is hang on, is this not just checking?
So here
we could just do
is
this,
ASCII,
right?
We probably want to check the isCompact flag first.
Yeah, we can swap it around
and return early if it's not there.
Which, funnily enough, reads more like the
yeah.
the name of the function anyway. And that's good enough to you like that? I think it makes sense.
Yeah. Wait, this is a compact ASCII string or not? So if we're already compact, then we know lazy ASCII is correct.
So we could just go back to it.
Yeah.
Yep. Yeah. Okay. We'll go back to that. That's the error I had previously.
Just
we've had to hit the same thing multiple times from different includes. Okay. Wow, this is garbled. Oh, that's because the mate J probably.
Whoa.
I put it too low, have I? Yeah. I'll put it up here.
All right.
And that takes.
We have no length, so that also needs a fill.
Mm-hmm.
And for kind, 2.
Yes, which is here. So that's currently a macro. We want to move it to. Our value just means that we can't assign to it, right? So making it a static inline function, if anything, is helpful here.
Yes.
Hang on.
Hopefully.
There's a GitHub a warning right in front of us.
Yep.
So hang on, but what this warning says that we should not do that. Shouldn't create an inline function. I guess we do it anyway. We live with the warnings. We deal with those later.
Okay, so we want a new inline function and we want the macro to call it, right?
Really? Why? Because the problem is that if we have
you know what we can do? We can convert the fill function to return the object, so you can use it in expressions.
I don't follow. Sorry.
So the new function we added, Unicode fill data or abort, we can have it return the object and then just use it in the expression.
Oh, right. Yes, that makes a ton of sense. And it's just going to forward it through now. So we can... Now we can just go here.
Yeah.
Do you want that broken out onto new lines at all?
Yes, eventually.
Perhaps like that.
For the demo, it doesn't matter. And add a return to that. Implementation, I guess. All right, now we have length.
That's fine.
So
If we change that.
Now. That can be.
Oh, yes, we need to change this to lazy kind. And maybe we're there.
Now just the Unicode object.c.
Okay, so this is where we can start checking the flags, right?
No,
No.
by Unicode UTF-8, so here
That's
we want
unchecked.
to fill.
This potentially is null, I think. In this one, we can just do surrogate escape.
But we want.
And this one is.
So this one needs to check. Yeah, this one needs.
Oh, you think here?
Oh.
This one's not doing any filling. So I think this can be okay.
This one needs to be renamed. We need to check all the called sites of this one.
Because it's... like this, you want?
Oh yeah, maybe it's better to name it as circuit escaped.
Change the field as well?
Yeah, change the field as well.
Okay.
That'll bring some new problems.
Okay, yeah, and then so this one is the UTF-8 representation. Hang on.
Yeah, so that's the public one.
Which can be... I'm just trying to think. This is the unchecked one, though, is it?
Yeah.
So do we do an...
It also needs to be renamed.
You want this to be surrogate escaped as well?
Yeah.
Okay.
Let's call the renamed one as well.
This is setter. Like this?
Yes. Oh, 125 you want to call the renamed function.
Oh, yes, sorry.
Right. UTF-8 length, that stays the same. It doesn't, because if you call it first...
and we called the field UTF-8 length.
Yeah, we need to set UTF-8 in this function.
Do we?
This is a public function. So if a user wants to copy the UTF-8 buffer, they call Unicode UTF-8 length, allocate the buffer, and then call Unicode UTF-8 and fill the buffer. So this one needs to give you the correct UTF-8 size.
Which is not necessarily...
Oh no, this is the unchecked. This is the unchecked getter. Well, let's leave this as it is.
You don't think it should be called surrogate escaped length? Or Unicode length? It's no longer UTF-8.
Yeah, I guess rename it as well, just so we check all the call sites. It's more work, but we'll be more sure that that's actually correct.
Yeah, okay, surrogate escaped length. Should we change the field as well? Probably.
Yeah, probably.
Height length?
Just call it surrogate escape. Just so we know which encoding this is in.
Okay, fine, yeah. Should I start with an underscore there? It feels better now. Or we seem to be going for an underscore everywhere else. Surrogate escape,
So,
that was the encoding, right?
yes.
But,
we'll need to make this structure private anyway, so underscores don't really matter.
okay.
Oh, yeah, the underscore in the middle. Yeah, definitely put the D at the end.
The D at the end. I like the underscore for consistency with everything else going on now.
Yep, let's do that. Yep.
Okay. We're going to have a number of those to fix. Okay.
Right.
And then this can be set surrogate escaped length. Right. Oh, this is lazy length. Oh, but if it's compact ASCII, we know it's valid, so that's fine.
Right.
Okay, and now we have Unicode share UTF-8. I have no idea what this is. Oh, whether they're the same.
It sets the UTF-8 pointer to the data pointer.
No, this is checking it. It's not Simon.
Oh, checking. Right. Yeah, so that can use the lazy.
Yeah, it can just do it without any concern, can't it?
Yes.
Where are we? There. Okay.
That's compact anyway.
Now we've got the... That might be okay now. Yeah, because that was just...
Just recompile.
Unicode UTF-8.
So has UTF-8 memory. True if Unicode object has an allocated UTF-8 memory block. So definitely. So get a skip there.
Okay.
Check consistency. Okay, so we want the lazy kind here, and then see where we check it later.
Yes, because it's just being checked here or here.
Let's rename the local as well to lazy kind.
Yeah, sure. No, my language server's really not working today.
That's good. You don't want to refactor. You want you're renaming because you want to check every call.
Work there. Okay. That looks okay.
And 624 as well.
Thank you. And there and there.
Right.
Okay. And this is lazy ASCII now. What? Maybe should we use the macro here?
Yes. Actually, this is the check, so don't use the macro. Use lazy ASCII here.
Isn't it the same? The macro didn't change anything. We made the macro. The macro doesn't change anything. It just seems like a better way to do it, doesn't it?
I think we want to be explicit in this checker here.
Okay, if you're sure. Okay, because we're checking the state. Fair enough. Okay, and then in these checks, it's just going to be checking that. Might as well check the length, right, as well, in the same way. We can be consistent. Hold on. But this is now lazy ASCII, which could be, well, it's fine. If it's not set, then we know we're okay.
Yep.
But the data must be set, so lazy ASCII must be set.
Yep, that's good.
We're still in the check. Yeah. We know we must be. Hold on.
Yeah, this is the else.
Compact is 1.
Lazy ASCII is 0 because this is the else from the ASCII and backwards.
And if it's compact, we're never in this our new branch. Okay.
Is it circuit escaped size? What's the name of that function?
I'm sure we wrote it with length, didn't we? Oh, it's not got an underscore.
And that's lazy length.
This is a macro, presumably. Okay.
What is PyCore debug offsets?
This is some structure about.
The
length offset.
Yeah, just rename that to lazy.
In both cases?
Yeah. Debuggers will need to cope.
Yeah. Okay.
there.
And this is surrogate escaped. What's going on here? If there is no it makes sense that if there's no data, the length is 0.
Right.
There's a check there.
Since you're touching this, you can put the curly braces around the body of the if.
Like this.
Yeah. No, that will the first one goes on the previous line.
I think I was inconsistent with that somewhere else.
Doesn't really matter for a demo.
Okay. Do we actually use compact now? We don't need that cast at all. Because we're doing it through the accessor, which we could drop if you prefer, and go back to...
That's fine. If we take this out of demo, we'll probably want to do that, but...
oh, no, we did need that. I'm being daft. Okay, let's look at this. So this is data. Data's guaranteed to set it. So we can get away with that.
Mm-hmm.
This is lazy kind. We set it.
Yep.
And we must be... Oh, hang on.
Our Unicode data must have set it, so we probably need to reread it.
I think we need to reread it, yeah.
Sure. Well, just name it kind now.
Should we get it properly?
Yeah.
Like this.
Yes.
We need to declare it though. Int.
Probably. And it's also just a few lines down. Yep, there.
Mm-hmm. Oh, Pycode. This is probably okay. And lazy ASCII.
Yep.
Because these are static allocators, so that makes sense. What's this? Resize in place. Okay, fine. In all these cases, we probably just want to change it to be has surrogate escaped memory.
Yeah.
I think we could just rename this one. It's almost certainly going to be fine. Now we need to free the thing and set it again here. Actually, I'm going to type surrogate escape so much I might as well just copy that onto the buffer. Right. Now, same here, isn't it? Set the... We've set the
Now here we're sharing the UTF-8
This is
representation.
we're sharing it, yeah. Did we rename this one? We didn't rename this one yet. I guess we do want to rename this one. It's only used in one place anyway.
Yeah.
Okay, so if we're sharing, then we're just setting the data. That seems fine. I'm more or less out of time, though it'd be nice to at least compile. But we've got the function, which is still not doing anything, so we might not get very far after that.
Yeah. I mean, it'll take some time to go through all of this, but I think we're on the right track here.
I'm just going to read that again. No, because it's not a ASCII state.lazykind. Let's read it like this. If we're checking the content, if the kind is set, it must be that in one, so that must be fine. This is now checking that there's a null terminator, which again but this is probably going to start failing if check content is set and the data's not. Oh no, because we fill the data right there. We're okay.
Fill the data. Probably don't want to do that in the checker. Just do
Yeah.
Yep.
Yeah. Okay, we've still got a lazy length needs to be set.
And we need the Unicode set length. Yeah, this will take a while.
Yes. We're not going to get to a compile today, are we?
No, we're not. But we'll get there in a month.
Yes, it looks like that. Well, shall we write a quick note for ourselves so we can remember where we are?
I just compile.
Or we'll just compile it and pick up again next time?
Yeah.
All right, let's do that. Okay, so
could you commit this as a temporary commit and push it?
Sure.
To your branch.
I can push it to a public branch. Sure. Yeah. I obviously can't push to Python CPython, so I guess we'll be there in a moment. Okay. So that's the branch for what we did today.
RUTF-8. Anybody wants to?
I can share that in chat.
Yeah, already did.
All right. So next time, I guess we'll hope to continue that compile. Looks like it's not, well, that's all Unicode object.c is still...
A bunch of them will be repeated.
Yeah, so changing the accessor macro will fix a lot of things. And then we'll have to implement the fill data function, which shouldn't be too bad, because that should be take the buffer and do the decoding, pass on it with the surrogate escape handler, right?
Yeah, we probably need to pull apart the allocation of the object from filling its data, but
yeah, okay. Oh yeah,
we'll
because
do that.
it's sort of going and it's normally done all in one, but that's fine. Okay, great. In which case, let's pause the stream here. Thanks very much for everyone who's checked in today, and we'll look forward to continuing it next time.
Which will be...
Good question. I think, are we expecting to do it at the end of May? We had been intending to do roughly at the end of each month, but we ran a bit late on the April stream for various reasons, so I have it in for the 29th of May
Sounds
at the
good.
moment. And for various reasons, I can't do the weeks either side, so I'd be surprised if we move it. So 29th of May looks like a promising one. All right. Cool. Well, thanks everyone again.
Right.
Bye for now.
Bye, everyone.